And again, remember, there are recordings of every single session that we have done this term. So if you miss a class, you can always, I can see who's watched the YouTubes. So if you didn't get to, if you weren't here in person because of whatever reason you were, I still can give you credit if you've watched the YouTube and done the work. Again, of course, the important thing is to keep current with the work, to keep current with all the assignments, with the homeworks, with the tests, and to do well on them. Okay, so let's look at this problem here. Um, it says solve the equation x plus 7 squared equals -4. And I gave it as a multiple choice question and actually was on a recent final exam. So this is really something you should know how to do. And if you recall, we did something called the square root method, which looks like a good method to use for this particular example. We have that the x plus 7 squared equals -4. And we know when we have something squared equaling a number, we can take the square root of both sides. And when we take the square root of the x plus 7 squared, of course, that'll just give us the x plus 7. In other words, the square of anything, when you squared it and then you take its square root, you're right back to where you start. On the other side, since this -4 is not in the square root, I have to actually do the square root. And don't forget that you have to get two answers for that square root, the plus and the minus. You get plus or minus the square root of -4. And after this, it's all just simplifying. We know that the square root of -4 is 2i. The negative makes it an I, so this becomes plus or minus 2i. So we get x plus 7 equals plus or minus 2i. But I want to get what x is, so I have to bring the 7 to the other side. So I have to subtract the 7. Remember, what I put on the other side of the equation always, in this case, goes in front. So the -7 goes first, and then I have plus or minus 2i. And that really is two answers, -7 plus 2i and -7 minus 2i. Notice these are not like terms. They can't be combined any further. So we could have actually left our answer this way, and actually that is the choice that they gave us. But sometimes they might have given us the choice as two separate answers. Again, if this would have just been a 2, for example, then we could have gone further and simplified. But in this case, they are unlike terms. This is a real number, the -7, the 2i is an imaginary. Together, my answer is a complex number, but I can't combine the -7 with the 2i and make it into a single number. Does anybody have any questions on this? Okay, Evelyn, I happen to agree with your answer. Thank you for sending me the answer. The answer is indeed choice A. All right. Now let's go on to where other things that we had covered on Thursday. We talked about solving quadratic equations. And that's what we're going to be finishing today. We're going to be finishing our discussion on quadratic equations. If we have time to go beyond that, we'll do something beyond that. And obviously, the type of question we just did was a quadratic equation.
Professor, I have a question.
Sure.
It's Amy.
Amy, thank you, Amy. I love when you ask me questions.
The test, it says 11. What is it due?
It's going to be available from 11:10, that's today, this afternoon, until the 17th, which is a week from today.
Okay.
After that, it'll still be available, but there'll be a penalty of 10%.
Okay. Thank you.
Okay? Everybody understand that? Okay. So we talked about two new methods of solving quadratic equations. Just getting my papers. That can be used to solve equations that don't work by just regular factoring. And as a matter of fact, we actually could use these methods even if the original equation is factorable. And what I'm going to do is I'm going to take a quadratic equation and I'm going to solve it three different ways. One, I'll give you, as again, not every equation can be solved all three ways, but it'll give you an idea of what method you prefer. And again, very often you'll just be faced with a quadratic equation and you'll be told to solve it. And you have to know which of the methods you want to use. So let's take this one. This equation is x squared minus 13x plus 36 equals 0. Remember, we realize it's in a quadratic equation because it has this x squared. The first method we used that we learned back when we first learned how to factor was what I call the factoring method. Let's call this the factoring method. What's going to happen is I'm going to have to be erasing some of these as I go along because I just need the space. Okay. Okay. We try and we get it equal to 0. It always has to be equal to 0 if we're using the factoring method. We try and break it up into two parentheses using our factoring expertise, our trinomial factoring. The x squared we break up into x and x. I look at the final term, it's negative, it's positive, which means both signs have to be the same. And since the middle term is negative, that means both of these signs are going to be negative. And we're looking for two numbers that are multiplying to 36 and adding to 13. And I think everybody might realize that those two numbers are 4 and 9. In other words, this particular example did factor. If this would have been 37, for example, instead of 36, there wouldn't be two numbers that multiply to 37 and add to 13, and we couldn't factor it. Not every trinomial is factorable. So this factoring method, it's great when it works, but it doesn't always work. If you remember, we don't stop here. We take each of the factors separately, x minus 4, and set it equal to 0, and the x minus 9, and we set it equal to 0. And then on here we add 4 to both sides, so this gives me x equals 4. And this I bring the 9 to the other side, and that gives me x equals 9. And my two answers come out to be 4 and 9. Remember, with a quadratic equation, you do expect to see two answers. Occasionally, the two answers come out to be the same number, so there's only one answer, but usually there are two separate answers for your quadratic equation. Simplest method, quickest method, it works as long as we can factor. Now I'm putting the answers over here, 4 and 9. Second method. Everybody okay if I erase this now? So this is going to be method number 2. You're going to see I will get the same exact answers, because if we don't, then we can't say they're different methods, that all the methods, no matter which one I pick, have to give us the same answers. Okay, so this is method number 2, and that method is called completing the square. Again, we're going to start with our x squared minus 13x plus 36 equals 0. Oh, actually, in this case, I do not want to use the completing the square method. I only want to use the completing the square method when the number in front of the x squared is 1, which it is. In other words, my leading coefficient is 1, so that's good. And the number in front of the x is an even number, because I'm going to have to take that number and divide it by 2. Now, yes, I could take my calculator and I could get decimals and the method would work, but when I have that, I don't even go to that method. Again, we're not using that method for this one. So it's not a great method for this example. Under duress, if I made you, you could, but you'd be floundering with fractions and decimals, and it would be very difficult. So let's not use this method. I'm going to come back into an example where we can use the completing the square method. So the third method that we could use is called the quadratic formula. Of all the 3 methods, the quadratic formula is the most versatile, because there isn't a quadratic equation that can't be solved using the formula. If it factors, if it doesn't factor, if you can use completing the squared, if you can't use completing the squared. Every single quadratic equation, every single equation that has an x squared, or whatever your variable is in it, can be solved using quadratic formula. And if you walk out of this class learning just one thing, probably the most important thing you should learn this term is what the quadratic formula is and how to use it. Now here's what the quadratic formula looks like. Every single quadratic equation is of the form ax squared plus bx plus c equals 0. In other words, first of all, to use the quadratic formula, if you see you have a quadratic equation, if you see you have an x squared, you have to get it equal to 0, which we did even when we were factoring. The number in front of the x squared is called the a. The number in front of the b of the x is the b, and the number that stands alone without any x next to it is the c. Let's just write down what the a, b, and c is for this particular example. The a in this case, well, what's the number in front of the x squared? There's no number there, so it's understood to be 1. The b is a number in front of the x, which is negative 13. Don't forget that the sign comes along with a number. And the c is the number that stands along, which is the 36. So first of all, when you want to use the quadratic formula, you have to know what your a, your b, and your c is. Here's what the formula looks like. x equals, this is not so, it's not so important to say the x equals, but here's the important part. Negative b plus or minus the square root of b squared minus 4ac. This whole thing, this whole long thing is over 2a. And all we have to do is take the numbers that we've written down for our example, that are the a, the b, and the c, and fill it into the equation, into the formula. So here we are. My x is going to be negative b. So here's negative. Put those letters, when you take away the letters, put a parentheses and fill the parentheses with the proper number. The b is negative 13. So this is parentheses negative 13 plus or minus my square root. Now here's the first thing says b squared, so I'm putting a parentheses instead of the b. And it's the parentheses squared. What am I filling in that parentheses with? Again, negative 13 minus 4. Okay, now there's a parentheses for the a and a parentheses for the c. Again, you notice that I'm putting a parentheses wherever a letter is and filling that letter, that parentheses, with the proper value. So the a value is 1 and the c value is 36. And I put this the whole thing over 2 parentheses. A, the a is 1 again. And now what I have to do is simplify what I have here. The rest is all arithmetic. And I'm going to use my calculator wherever I possibly can to make things simpler. Okay, so here we go. X equals, well, the first thing I see is negative 13, which is positive 13, plus or minus the square root. Okay, now this is always the hardest part. The number that's inside the radical. First it says negative 13 squared. When you're doing negative, first of all, you could do it in your head. 13 squared happens to be 169. But be very careful. If you're doing it on a calculator, make sure you put it in a parentheses. Put it in a parentheses negative 13, close the parentheses and then square it. And you get positive 169. Don't make the mistake of not putting in parentheses, because then the calculator will give you negative 169. And you know that when you square a negative number, it has to be positive. Or if you want, just square the 13, because you know your answer is going to be positive. Okay, so the negative 13 squared gives us positive 169. Then I have minus, so I have negative 4 times 1 times 36, because I'm just multiplying these together, which gives me minus 144. So inside the parentheses, I get 169 minus 144. And when I do 169 minus 144, it gives me 25. So this number comes out to be 25. And this becomes 2 times 1 is 2. Now it turns out that the number inside my radical, in this case, happens to be a perfect square. It is rational. Sometimes this number comes out to be an irrational number. In other words, it might come out to be the square root of 17. So we don't have the square root for it. And sometimes it comes out to be a negative number, like the square root of negative 25, and then it becomes an I. So this number can be rational, just a regular perfect square. irrational or imaginary. In this case, it's rational, so I'm going to put its value, the square root of 25 is 5. And this gives me, now I separated it, 2 answers. 13 plus 5 divided by 2 will give us 1 answer. 13 minus 5 divided by 2 will give us our other answer. Now, if these are not, if this would be something with an I or a radical, I couldn't go any further. But I can on this because these are rational numbers. 13 plus 5 gives me 18. And 18 divided by 2 is 9. And 13 minus 5 is 8. And divide by 2, that gives me 4. And guess what? I got the same 2 answers, 4 and 9. So that's how we use the quadratic formula. Very important. Your setup is very important. Write out your formula for yourself. Write out your A, your B, and your C. So then you can solve the equation. Okay, I'm going to now do one in which we can do the completing the square, because that method I didn't show you. Again, we will use a completing the square method if the number in front of the x squared is 1. In other words, it just starts with a positive x squared without anything in front of it. And if the number in front of the x is an even number. Does anybody, can I erase this before, so I can go on to another problem? Anybody having a problem? Okay. Okay, thank you. So I'm going to now put on another problem on the board, and I'm going to demonstrate how we do the completing the square method. And then I'm going to give you that same problem and ask you to do it using the quadratic formula. Next problem. And I will leave this on for later problems, so we'll just use that as our reference. For next time, make sure you know this formula by heart. Okay, here's the problem. X squared plus 6x plus 3 equals 0. Okay, this is a quadratic equation. By the way, I think you might notice that the quadratic, you can't use factoring on this because I can't think of any numbers that multiply to 3, but when we add them, give me 6. So obviously I couldn't use the factoring method on this one. I'm going to do the completing the square method on this, and then I'm going to give you time to do the exact same problem using the quadratic formula. That'll give you an idea of which method you like better. Again, the completing the square method, though it could be used in any problem, is for practical purposes, we need the x squared to be standing alone. In other words, its leading coefficient is 1, and the x to be, the coefficient has to be even, which is exactly what we have here. So here we're doing the completing the square method. Call this is method B, I think we call it. When you're doing the completing the square method, this is the one case when you take your quadratic equation and you don't want it equal to 0. You want to bring any number that doesn't have an x next to it to the other side of the equation. So all you're left with is an x squared and the 6x. In other words, you isolate the x terms and anything else is on the other side. Even though you remove this, you want to leave the space for it because we're going to be adding something here. That's why we call it completing the square. To figure out what we add, remember the method. We divide this number by 2. That's why we want it to be even. So positive 6 divided by 2 gives me positive 3. And I multiply that by itself. 3 times 3 gives me 9. And I add 9 to both sides of this equation. Again, remember, half of this number squared is 9. Whatever you add over here, you add over there. Okay, now that makes this into a perfect square trinomial. This is a perfect square. And what it is x plus 3 squared. That's why I put down the 3, because the number that the x is always the start of the binomial. The second number, the number that stands alone without any x, is always half of this number and also the square root of this number. Of course, it's easy, since we had to find this number by doing half of this, that's the number we use. And notice, since this is a positive 6, the number in here becomes a positive 3. On the other side, we just combine those numbers. Negative 3 plus 9 is 6. And now we can use our square root method. So that taking the square root of both sides, we get x plus 3 equals plus or minus the square root of 6. And then to finish this off, we want to bring the 3 to the other side, so we have x alone. And again, remember that the number that you bring over, that always goes first. So negative 3 plus or minus radical 6. Now, this is not a rational number because there's no square root. There's no perfect square root of 6. So we want to leave our answer in this format. Negative 3 plus or minus radical 6. Again, if you had wanted to, you could write it as 2 separate answers. Negative 3 plus radical 6 as one answer. Negative 3 minus radical 6 is the other answer. I'm perfectly happy with the answer being written like this. But if you want to write it 2 separate answers, this is a shorthand of writing these 2 things. Again, we can't combine them because they are not like radicals. This is not, we can't simplify this any further, so this is our answer. Okay, so this is the completing the square method. I'm now giving you a few minutes to do this exact problem using the formula. We'll go over that in a minute. While you're doing that, I will take attendance. And let's go on. Okay. Let's remember that our answers are, I'm going to put the answer right over here. Negative 3 plus or minus the square root of 6. And let's use the formula to solve this. I'm going back to here. Obviously, you don't have to use all the methods. Use the method you like best that makes sense. Obviously, you can't use factoring on a method where it doesn't factor. And you're not going to use the formula on a method where you don't, the completing a square, where you don't have a leading coefficient of 1 and an even coefficient of the x. But the quadratic formula you could use in any case. So the first thing I always like to do is write out what the a, the b, and the c is. So the a in this case is obviously 1 because there's no number in front of the x squared. The b is positive 6. and the C is positive 3. And now I'm going to stick those numbers, substitute those numbers into my formula. Here, my first thing I have is a B. Remember, I put a parentheses for the letter and fill it in with the number. So the number I'm filling in for the B is 6. Then there's a plus or minus. Here's my B squared parentheses. Again, that's the 6 minus 4, and then there's a parentheses for the A, and right next to a parentheses for the C. The A parentheses is 1, the C parentheses is 3. And this whole thing, don't forget, it extends the whole length, not just the square root, but the whole length over 2A. Here's my parentheses for A, which is again 1. And now it's a matter of simplifying. So this becomes, well, a negative in front of a parentheses is just the negative. That's negative 6, plus or minus. Now here's the important thing, the hard part. 6 squared, which I know is 36. And this is negative 4 times 1 is negative 4, times 3 is 12. So this becomes 36 minus 12. So in my parentheses, 36 minus 12 becomes 24. That's what goes inside the radical over 2 times 1, which is 2. And what I have to do is simplify it. And I notice that the radical 24 can be simplified because I could break it up into 4 and 6. And the radical 4 becomes 2. So this becomes negative 6 plus or minus 2 radical 6 over 2. And I have to simplify this. And the way I simplify it is I look after the radical is simplified, I see if I can divide out a number from all 3 terms that I see. I see a negative 6, I see another term is 2 radical 6. Those are the 2 terms that are in the numerator. There's a binomial in the numerator over 2 in the denominator. And if you notice, 2 goes into each one of those terms. The 2 into 2 will give me 1. The 2 into the negative 6 will give me negative 3. And the 2 into the 2 radical 6, remember, when you're dividing a number, numbers outside radicals can only divide into numbers outside radicals. And there is a 2 outside that radical. So that this ends up being negative 3 plus or minus 1 radical 6, which is just radical 6. And it's all over 1, which is, we don't have to put that in. And here's my answer, exactly the answer I got when I was completing this square. Just by the chat. How many people got that answer? Anybody got that answer? Okay, Teresa, great. If you came up with this answer, this is not simplified enough. Even this is not simplified enough. Don't forget, when you're trying to simplify it, very often you're going to have a 2 in your denominator. You're going to want to try and divide all the terms by the 2. So, but don't just divide the 2 into the negative 6. This 2 is over everything is over the 2, so you have to divide the 2 into both terms. Okay, I wanted to show you one other thing. Sometimes, I'm going to erase a little bit of this, so I need, because I need this like, oh, okay, I'm going to write here, do it right here. This answer is an irrational answer. It has a square root of 6, and 6 is not a perfect square. We usually leave our irrational answers in what we call simplified form. One answer is -3 plus radical 6. One answer is -3 minus radical 6. Again, we usually leave it with a plus minus sign. But sometimes we want the answer in a decimal format. How do we get a decimal format? Now you can't do a decimal format if the number inside the radical is a negative. With an I, you have to leave it the way it is. But if you have just a radical, like a square root of 6, you can get your answer in a radical format by using your calculator. Let's say I want my answer to the nearest 10th. I go to my calculator. I hope everybody knows where the square root button is. I go to the square root of 6. And when I do the square root of 6, here's the number that I got for the square root of 6. The number I got for the square root of 6 is 2.449489. I'm not even putting any word. It's an irrational number, which means it's a non-ending, non-repeating decimal. If I want my answer to be, my final answer to be the nearest 10th, I would take, well, let's take 3 decimals. Just take 2.449. Replace the 6 with 2.449. So then you'll get, for one answer, -3 plus 2.449. And the other answer will give you a -3 minus 2.449. In other words, go to about 3. You don't have to put in all 10 digits. Go to 3 spaces after the decimal and take that number as a rounded off version. And then just do this on your calculator. -3 plus 2.449 gives you -0.551. But remember, I told you I wanted to round it to the nearest 10th. So when I'm going to the nearest 10th, I look at the number after the 10th place is the first digit after the decimal. I look at the second digit after the decimal. If that is 5 or more, I have to make my number before it higher. So this becomes -0.6 and round it off. Then I go to this, -3 minus 2.449, and that gives me -5.449. Again, I want to round off to the nearest 10th. So I look at the digit after that, which is a 4. It's less than 5, so I just leave this -5.4. So this is if you're asked to give your answer to the nearest 10th. If they ask to the nearest 100th, then you go to 2 decimal places. In other words, you take the -5.551, and this is the way you'd have to do -0.55. And here you'd have to do -5.45. So you can get your answers in decimal form as well. But of course, you need a calculator for this. If you haven't gotten a calculator yet, you better get a calculator now. Okay. Would you like to do one more example like this? Should give you some time to try another example using the quadratic formula. I think that's a good idea. So let me take an example. Take one off of a final exam. Okay, so I'm going to write another problem on the board. I'm going to leave this on so that if you want to use, you have the formula right in front of you. This actually was from a final exam, which was the spring 2019, so it wasn't so long ago. Here's the equation: x squared minus 4x plus 29 equals 0. I'm going to give you about 4 minutes to solve this. I'd like you to use the quadratic formula. After you've done that, see if you could get your answer to the nearest hundredth. That hundredth is 2 decimal places. Okay, I'm turning off the video. I'm pausing it while you do this. Okay, I think we should get started again with this. Again, actually, this one could have been done using the completing the square method because it starts with a plain x squared. The leading coefficient is 1. In other words, my a is 1. And my b, the number in front of the x, happens to be even. But I asked you to do the formula, so I'm going to do it with the formula. Again, if you do it with the completing the square method, you should get the exact same answer. Using the formula, the a we said is 1, the b is -4, don't forget that negative, and the c is positive 29. Okay, so I'm now going to stick those numbers into my formula. So it's x equals -b, here's my b, in place of the b I put a -4, plus or minus, here's my square roots, b squared, here's my parentheses squared for the b, again that's the -4, minus 4, one parentheses for the a, and right next to it a parentheses for the c. The a is 1, the c is 29. And this is all over 2a, 2 times 1. Okay, and now we simplify. -4 is +4, plus or minus the square root. Okay, the -4 squared is +16, and -4 times, and remember, I have to use the negative, not the minus button. -4 times 1 times 29 gives me 116. So this comes out to be 100 minus 116, which comes out to be -100. I'm not going to be able, this is not going to come out to be a decimal. And this is over 2. You always look at the radical. Can we simplify it? And remember, when you have the square root of -100, that really means the square root of 100 times the square root of -1, which is 10i. Don't forget, this would be an I because the number inside the radical turned out to be negative. So this becomes 4 plus or minus 10i divided by 2. And if you notice, all the 3 terms, the 4, the 10i, and the 2 can all be divided by 2. This becomes a 1, this becomes a 2, and this becomes a 5. so that my answer comes out to be 2 plus or minus 5i. There was no decimals involved, so there's no hundredths to deal with. And you could leave your, again, you could leave your answer like this, or separately as 2 plus 5i is one answer, and 2 minus 5i is the other answer. I have them like this because it's efficient, but on a multiple choice test, sometimes they give it this way, sometimes they give it this way. These are complex roots because the number inside my radical turned out to be a negative number. Any questions about that? Any questions? How many people were able to get that? Okay, great, Carmelita. I hope a bunch of you got it, that answer. Okay. I think, so that takes care of basically chapter 7. We're going to be going on to chapter 9. Again, this is not covered on the test on Delta Math. We will have another test after we finish chapter 9 that will cover chapters 7, quadratic equations, and chapter 9, which is the chapter we're going to be starting now. I'm just going to give you an introduction to it. We're going to do a little bit, and of course, we're going to continue on Thursday. Again, if you come across any problems in the Delta Math, please email me that if you want me to go over something in class, I'll go over it for the whole class. Or if you want to meet me, again, I'm always available. Those who come on early see, I'm basically available from 9:15 in the morning, 9:20. I'm sitting at my computer with a Zoom on. You can always come and ask me a question then. You can ask me a question in class. Just do the work and make sure you understand it. If there's something you're having a hard time understanding, bring it up because you're probably not the only person. And we want everybody to understand as much as we can. Okay, so this is, again, there'll be another test after this on chapters 7 and 9. I'm not sure whether I might do that. I haven't decided whether that'll be on the Delta Math or on the Blackboard, but certainly before the end of the term. We have chapters 9 that we're starting now. Then we have chapter 8, which is something called exponents and logarithms. And then we have a chapter that's not in the book, that's trigonometry, it's sines and cosines for those of you who know what it's about. So those are the 2 chapters. So we have a total of 3 chapters, 9 that we're starting now, 8 that we're going to do after that, and trigonometry. And before the end of the term, I will give you another test on Blackboard. It might be more than one, but for sure one test on Blackboard that will be a practice final. Just like I gave you a practice midterm, there'll be a practice final, so you'll have an idea of what to expect on the final. The exact date of the final, I don't know, but it's going to be probably around shortly after the 10th of December. And there is homework on this chapter on Delta Math. There's a lot of homework on quite a few problems on the quadratic equations for you to practice these examples. Okay, the topic that's chapter 9 is something called conic sections. And we're going to be going back to discussing graphing. At the beginning of the term, chapter 2, I think already, we talked about graphing of linear equations, how to graph lines. We're now going to be talking about graphing of quadratic equations. In other words, equations that have an x squared in them. And since quadratic equations are more complex than linear equations, y equals 3x plus 2 is not as complex as, let's say, y equals x squared plus 3x minus 5. We're going to see that the graphs that we get from quadratic equations are more complex. For linear equations or first degree equations, equations that don't have any x squares in them, there's only one type of figure that we get. It's called a linear equation for the simple reason you get a line. Sometimes, most of the time, the lines are what we call slant lines, but sometimes we have lines that are horizontal or lines that are vertical, but we always get a line from a linear equation. That's why it's called a linear equation. From a quadratic equation, we get 4 types of figures. One type of figure we could get is a circle. The second type is something called an ellipse. The third type is a parabola. And the fourth type is something called a hyperbola. Now, I have a feeling you know what the shape of a circle looks like. Something like this. Sometimes the center is right at the origin, sometimes the center is someplace else. But what makes something a circle is that all the points on the circle are the same distance away from the center, which we call the radius. So a circle is one type of figure we get when we have a quadratic equation. An ellipse is like a flattened out circle. Sometimes we call it an oval. Something like this. I know that's not a very good picture, but if you think about the planet Earth, planet Earth isn't a perfect circle, happens to be sort of flattened out at the North and South Pole so that you get something called an ellipse. Where we also say ellipses when we talk about the orbit of the Earth around the sun. That's not a perfect circle. That's sort of an elongated circle, a flattened out circle, which is called an ellipse. It's called an elliptical orbit. It's another thing that you might get from type of picture you might get from a quadratic equation. A parabola shape is basically U-shaped. It's not exactly U-shaped because the sides don't go straight up, they sort of keep going out further and further. But basically, you get this U-shape. Sometimes it's U-shaped up, sometimes the U-shape is upside down. But that's what a parabola looks like. And a hyperbola is the most interesting of those. Is something that has 2 branches. Sometimes the 2 branches, they are 2 branches that sort of face away from each other. Sometimes they are crossing the x-axis. In other words, they're vertical branches. And sometimes you have them crossing the y-axis, which means they're sort of horizontal branches. But they're 2 branches. The graph itself consists of 2 pieces that are facing away from each other. What we're going to be looking at now, we're going to spend more time on the circle and on the parabola than the ellipse and the hyperbola. but we're going to be able to look at a quadratic equation, and from certain features that it has, we should be able to tell which of these four shapes we're going to get. Now, the reason these are called conic sections come from the word cone. Think about having an ice cream cone. Here's an ice cream cone. Let's say there's an ice cream cone right on top of another ice cream cone. One facing up, one facing down. And what do you do when you section something? When you're saying, let's section something, what we're saying is, let's cut it. Well, let's cut this cone straight across. And you're going to think about it. You're holding the cone in your hand, you cut it across, and you're looking down at the cone. Remember, this is an empty cone. So what is the shape that you're looking at? You're looking at a circle. This, the top of the cone, that's a circle. Well, what if you weren't so careful, and instead of cutting the cone straight across, you cut it sort of at an angle? Then if you would be looking down on it, because it was cut at an angle, you wouldn't get a perfect circle, you'd get an ellipse. If you cut your cone, let's say like this, really, not really, like not straight down. Let's say you cut your cone like this. So part of it is crossing outside the cone itself. You would probably get something, if you look at it, that would be an ellipse. It would be this U shape that you would be getting. So you would get a parabola. And if you cut straight down, so you cut both of the cones, you get something like this. One curve going this way, one curve going that way. In other words, you get a hyperbola. All I'm talking to you about is immaterial. You don't need to know that. The only gives the reason why these are called conic sections, because they're really the shapes you get by cutting a cone or two cones in different ways. But what do you have to know? You have to know when it says we're discussing conic sections, or what is a conic section? It means the four shapes here: circle, ellipse, parabola, hyperbola. I've seen a question on a multiple choice. The following is not a conic section: circle, ellipse, parabola, rectangle. So obviously the answer would be rectangle, because the others are conic sections. So you have to know when the word conic sections is used that it refers to these four shapes. We're going to do this in order. We're going to start talking about the circle. Let's talk about the circle. We'll start with a simple circle, and then we'll go to one that's a little bit more complex. Remember, we're going to be talking about this in terms of what they look like on a graph. So therefore, we're going to be talking about their equations as they refer to the graph. So here's the graph. Remember, this is my x-axis and this is my y-axis. The simplest type of circle that you can get on a graph is a circle where the center is right at the origin of the graph. And then let's say you have a radius of 4, 1, 2, 3, 4. It means it's going 4 in all directions. That's what a radius means. It's the same distance in all directions from the center. Now, this is not going to be exact. So you get something that looks like this. So this is the center of this circle is the origin. The radius of the circle I picked is 4. Those are the two important things that you're going to always need to know about a circle. Where is its center and what is its radius? If the center of the circle is at the origin, the equation of that circle is x squared plus y squared equals r squared. In other words, in the circle's equation, you're going to have both an x squared and a y squared in it. Remember, I told you it's going to be a quadratic equation. Sometimes in a quadratic equation, you'll have an x squared and not a y squared, or a y squared and not an x squared. In the equation for the circle, you have both x squared and y squared, and it equals r squared. Now, in this case, the r was 4, so for this particular example, we get x squared plus y squared equals 4 squared, which means that we get x squared plus y squared equals 16. And when I see an equation of this format, x squared plus y squared equal a number, I know that it stands for a circle and that its origin, the center is at the origin, and the radius is whatever the square root of this number is. So if I were to give you something like this, x squared plus y squared equals 25, again, you'd know it was a circle and the center is at the origin, but in this case, what would the radius be? Since this is my r squared is 25, my radius has to be 5. So this is, it's just a matter of knowing this is the pattern. X squared plus y squared equals a number squared, and the square root of that number is what the radius is. Obviously, this number always has to be a positive number. Now, not all circles have their center at the origin. What happens if I have a circle with the radius, the center is someplace else? So let's look at that. That's a little bit more complicated. Suppose I had something like this. Suppose I have a circle whose center is 3 across and 4 down. In other words, at the point 3, negative 4. I'm drawing these lines so I can draw. These are not part of the, I really probably should draw it as dotted lines because they're just there to help me draw. They're not really part of the graph. And let's say my radius is 5. How would I draw that? Well, I'd start at the point 3, negative 4. And then in all 4 directions, I would count 5 boxes. Remember, I'm doing this on graph paper, not just here. So here's 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. 5 to the right. 1, 2, 3, 4, 5. 5 to the left. 1, 2, 3, 4, 5. Okay, so to draw it, I know my radius is going to be 5, so I have to go 5 in all four directions. And then I just don't make straight lines. It has to be like a circle. Here's my circle. Here's what that circle would look like. But what is the equation of that circle going to look like? The equation of that circle, the standard equation of a circle whose center is at the point A, comma B, has this formula: x minus a squared plus y minus b squared equals r squared. Again, you're going to have something, an x squared and a y squared term, but the x is going to be inside of parentheses with a number, and the number it's going to be inside the parentheses with is the center, the x center. And the y is going to be in the center, in a parentheses with the y value. So that the equation comes out, and you're going to be careful about this. Here's what the equation turns out to be. X minus a. Well, a is 3. Because the 3 is the center. Remember, we said 3, negative 4 is my center. So that'll be x minus 3 squared. And y minus b, the b in this case happens to be negative 4. So I have to do y minus negative 4. A minus and a minus becomes a plus. So this becomes y plus 4 squared. And that equals r squared, which we know is 5. So 5 squared is 25. The equation of this circle would be x minus 3 squared plus y plus 4 squared equals 25. Let's be careful. The 3, there's a minus 3 here, means that the center is positive 3 for the x. This is a plus 4, so the center for the y is negative 4. It's always the opposite side. And the radius is the square root of this number, which is 5. So we can look at the equation of the circle. We recognize it's an equation because it has an x squared plus a y squared equals a number squared. And the number, and we'll even be able to tell what the center is because I just look at the numbers inside the parentheses and switch their signs. The x is going to be a positive 3, the y is going to be a negative 4 for the center. Again, the important thing about a circle is where is its center and where is its radius. Let's say I gave you this. X plus 1 squared plus y minus 3 squared equals 16. Now I know this is a circle because I have this x something with the x squared and the y with something squared, but it's not, doesn't have its center at the origin because there are numbers inside the parentheses with the x and with the y. The center, I can tell you what that is. It's negative 1, positive 3, because I just take these numbers and switch their signs. The radius is the square root of 16, which is 4. And of course, now, once I know its center and its radius, I would be able to graph that. Let's go backwards. What if I tell you that I have a circle whose center is 5, 0, and whose radius is 6? what would the equation of that circle be? Okay, so we're going to remember the equation of the circle is x minus a squared plus y minus b squared equals r squared. So it's going to be x minus 5, it's always the opposite side, squared, plus y minus 0, because this number is 0 squared, equals 6 squared, which is 36. Now, of course, I could make this a little simpler, because y minus 0 is just y, so this is just y squared. So this becomes x minus 5 squared plus y squared equals 36. Again, if there's no parentheses around the variable, it just means that the center of for that one is 0. So this would be, and if I wanted to draw it, here's what it would look like. The center is at 5, 0. So 5 to the right, 0 right on the x-axis. And its radius is 6, means I'm going 6 in each direction. 1, 2, 3, 4, 5, 6. 6 up, 6 down, 6 to the right. So you get something like this, where the center is on the x-axis, but not at the origin. So that takes care of the circle. We're going to do one other thing with the circle. That's what we're going to start with next time. And we're going to leave this right here. Any questions? Okay, then I'm going to end class. Don't forget to look for this afternoon, sometime between this afternoon and next Tuesday, do that test on Delta Math. Now, that's not a timed test. Delta Math tests are not timed. But make sure you get it done and make sure you're doing all the homeworks. I think we're up to homework number 14 at this point. So make sure you get them done. And again, I've extended, the only thing that I haven't extended is the due date on the midterm. That's passed. If you did not do the midterm, it's something you must do. You have to get in touch with me so I can extend the due date for you personally so that you can take it. Obviously, there's going to be a bit of a penalty, but if you don't take the midterm, then you get a 0 for the midterm. So make sure you get everything done. You don't want zeros for them. Okay, I'm going to end class here. Have a good day. I'll see you on Tuesday.